Great. Thank you very much. So just a little bit of background, because this research is based on a database that's available in the UK, which is called Energy Performance Certificates. And it's a standard tool that is used actually across Europe to assess the energy performance of buildings. It assigns a rating from A to G, A being the best scenario, best buildings, close above 92% score. And it's been around for over 2 decades. So as you see, that's why in the UK, just for residential buildings, there are already more than 27 million EPCs. So it's a very big database. It not only tells us what is the rating of the buildings, but also a little bit of information about what's the wall composition, what are the building systems within that property. So it offers a lot of information. But how it's done is an assessor visiting a building and then inputting some information, collecting some information. So as expected, there are some errors in these databases. Looking at academic research using these databases, we see that there is a big part of it looking at the data accuracy and reliability of this information. And the role that they play as a policy instrument. For example, minimum energy efficiency requirements in the UK right now is that any building that is below D, they won't be able to, the owner cannot rent it or sell it. They have to improve the performance. So it's a very influential database for policymaking and so on. But the main question that is still not answered is the scale of these errors and if they influence the results. So there are several studies that have looked at these accuracies. So one of the objectives for the start for us was to look at these studies, the methods that they have used, looking at possibility of integrating auxiliary data sets or machine learning for automating data quality checks, and also expanding the focus beyond currently most of those studies only look at EPCs that are repeated for the same property. So any discrepancy between the two, they flag that. So what if there is a property that only has one EPC? Can we also detect anomalies or errors in those? So that's another focus for us, and basically coming up with a comprehensive framework for doing such assessment. So without getting into too much details, these are the 4 main studies, seminal studies that we also based our work on, particularly for building on top of Hardy and Glue's work from 2019. And as you see here, most of these previous assessments are only covering EPCs or repeated EPCs, properties that have more than one. What we wanted to do is expand on the machine learning algorithm that they came up with, and also assessing the relevance of it if we look at different property type, different geographic areas, and so on. Just very briefly, I won't get into too much details. There are, of course, established methods for anomaly detection that if I pronounce the name correctly, Pasitni, in 2019 translated that for using assessing EPCs and identifying the errors in those. So we do look at those levels when we are assessing our framework, developing our framework. So this is pretty much the main chunk of our work. So what the methodology that we developed. So the database, as we get it, already has some level 0 verifications. So finding any spelling errors, but still there were some. So we corrected those for all of the database. Then we also used some building science logics to create a dictionary to look at cross variables within EPCs. So for example, you have several variables that are defining the heating system. So making sure that these are consistent. So we could do this for all EPCs. But then we introduced a conditional assessment based on data availability, and that defines if we can proceed with the following verification levels or verification ranks, basically, from V2 to V6. Verification tree is using external or auxiliary databases, which we looked at price paid data, and that also works for a certain number of variables within EPCs. But the main approach is level 2, V2, and V4 to V6. V4 to V6, all of these are using machine learning algorithms. And how it's done is that we first filter the data based on that condition and availability. Then we introduce 1/3 error, and we use a 80% training, 20% testing method for 4 different machine learning algorithms. And we look at the performance of each one of these methods. To test this framework, we tested it on city of Leeds, which is one of the most populated cities, one of the larger cities in the UK. And as you see, so for example, it has close to 400,000 EPCs. About 10,000 were removed because of issues or missing data. And then based on that condition that we defined, so for example, V2 is when we have more than 3 EPCs for the same property. And then you see the number of EPCs is reduced. So basically going from V2 to V6, number of data points increases. And then we look at the accuracy of each one of these methods. So I guess these are the main results. One factor is that V2, which was the more established method in the literature, has some limitations, and also the accuracy of results are much lower compared to when we look at properties that are in the same postcode or grouping properties that are in the same output area. But then also, as we increase the geographic boundary of our study, increasing the data points, the accuracy kind of goes down. So there is a trade-off between these verification methods, which is kind of our follow-on study. So the main conclusion is that we have now a framework, a validation framework, but the sequence of it is the main question for us now. So should we do, as you saw, so verification level 2, moving on, increasing the boundary, or actually reversing it? So that's what we are trying to look at. So identifying the anomalies through machine learning and then bringing in building science to see if actually these anomalies are valid or not. We are also looking at extendability of this approach. So now we are looking at Manchester as the alternative scenario. Yeah, and I guess the main point is that this is a must do for us because of this big database and the use of it in policy making. And we will continue this work, and just mentioning that the code and data scripts are available in case of interest. And I already covered all of these things. So thank you very much.